So my name is Alex Berkovich. I'm a principal machine learning engineer at Akridata. Akridata's latest platform, Data Explorer, is aimed for curation of visual data of any type, images, videos, to work with the cleanest data possible, to build applications and build solutions based on the cleanest data possible. And as you can all understand, we're now talking about data quality, and no one is better to talk to than Chad Sanderson, a true believer and the chief operator of Data Quality Camp. Welcome, Chad. It's great having you here.
Great to be here.
Anyone, just to note, if you have questions, by all means, please use the Q&A section. Chad, we're talking about data quality. Why is it important? Who?
Oh, hello? Can you hear me? Oh, there you go. You're back.
Okay. I was asking internet is still not available. I was asking, Chad, who is affected by poor data quality? Who uses it?
Yeah, well, I would say anyone in the business who has some dependency on data or who uses it to make decisions, whether it's an executive that's looking at a dashboard or a data scientist that is piping data into a machine learning model that's making some sort of prediction, or it's a customer that is looking at data that is pushed into some application that maybe tracks their spending or purchase history or something like that. Really, anybody that is exposed to data is also going to be exposed in some way, shape, or form to data quality. And data quality can be really great, and maybe the consumer of the data never runs into an issue where they doubt the data is wrong, or they're exposed to data that is incorrect and doesn't match their expectations. But more likely, there's going to be some challenge, some problem with the data where it deviates from expectations, it's incorrect, and someone could make a potentially wrong decision.
Absolutely. Do you think it's a recent issue, something to do with latest development in tech, something to do with maybe a cultural change, or has it been always like it?
I think data quality has been a problem for a very long time. Probably the earliest points in time when data was first beginning to get recorded. The problems have only changed and morphed, but they haven't gone away. I would imagine the very first issues in data quality were more about collection error. If I go and survey someone on the street, how do I know that they're actually telling me the truth? If I'm storing data maybe as rocks or written down on a piece of parchment, if my writing utensil smudges or part of that parchment is soaked in the rain, then when someone is trying to recount from my scroll, all of the number of chickens that I've stored in my coop, maybe it's not exactly accurate. That could potentially be a bad decision. Nowadays, we don't really have those issues, right? The data collection mechanisms are far more automated, and we have much better input validation and things like that, and we're collecting data much faster and in far different there's many different sources, both from applications and third-party sources and APIs and from IoT devices and things like that. But with that renewed range and speed and variety of data sources comes many different challenges as well, many different opportunities. Ultimately, what we're talking about with data quality is a human problem, right? It's people who maintain the collection of data not necessarily being in sync with the people who are reviewing or trying to make sense of that data.
That's a great point. I think the fact that it relies on the human error, potentially a human error, on not a bad aspect, just an error in how data should be handled. With the latest development with AI, we've also heard about ChatGPT and similar applications. Do you think it will be easier just to have some sort of AI bot or something like that to handle data than choose to leave it to humans?
I think, you know, if some people's beliefs about general intelligence come to be, then yes, like maybe a general intelligence machine would be able to handle these issues. But until there's a replacement for the human brain, ultimately it will be people making decisions on both sides of some data pipeline, right? You might have a software engineer who is managing a microservice, and they might decide that they want to treat their microservice differently tomorrow for whatever reason. They want to build new features and they want to collect the data for those features differently than they did yesterday. And there might be a machine, some artificial intelligence that can sit in between the producer of the data and the consumer of data, and maybe like help tell the consumer that something has gone wrong, but you won't be able to fix or prevent the data quality issue, because as soon as the human being who owns the data creation process makes a decision that violates the expectations of the consumer, then that data is wrong. You have garbage in the system, and it's just a question of how quickly can you recognize that the data is garbage and then do something about it. So until it's the machine that's making the decisions on what the microservices and the features and everything else is actually looking like, then the potential for human error really can't be prevented.
Thank you. And something I think we all know, something that you mentioned, that the human responsible for the data decides to change something with how they handle some microservice. AI systems probably can't be aware of all the business decisions, all the changes around the world. They could be political changes. There could be political changes within the company, right? And then you made some sort of change and it breaks things. And it breaks things. No one can predict that. No one can grasp the entire world of that data, and then things break. So you mentioned in terms of solutions, how do you see a consumer being able to use data that they don't fully aware of their quality? How should they treat that? They can't obviously check every piece of information they get. They need to work. So how do you think they should handle that?
Well, I think that there's stages of maturity to this. And not only are there stages of maturity to working with data quality, but there's also stages of maturity to any data asset. And what I mean by that is not every use case for data actually requires that much quality. So there's a range. If I am just building something purely experimental, like maybe I'm a data scientist and I think it could be interesting to build a particular type of model, then I might go out and, pull together some features and build a training set. And yeah, like maybe this data isn't the highest quality data in the world, but it gives me a good general idea of whether or not the training set is going to be predictive. I probably don't need an extraordinarily high level quality when I'm going through that prototyping, sandboxing, experimental process. In fact, in a lot of cases, most data scientists will just acknowledge that this data is pretty low quality and they're okay with that. The problems start to emerge when the use case switches from not really requiring a huge amount of accuracy and quality to now we've deployed something into a production environment. A customer could be interfacing with it, and the predictions that we're making from that model must be accurate. If they're not accurate, it could have a negative impact on the business. An example of this is when I was at Convoy, we were a B2B freight marketplace, and we had a pricing model, and that model would basically predict before we accept any shipment onto our marketplace, do we think that this shipment is going to be picked up at a margin positive price for Convoy? We had to fulfill essentially every single shipment on our marketplace. And if we couldn't fulfill it at a rate that was margin positive, then we would take it at a loss. So if that pricing model was wrong, and it was wrong by, say, 10% or 20%, that could have huge impacts on the business, like tens of millions of dollars or even hundreds of millions of dollars. So the confidence interval, that sort of range of accuracy, it needs to get smaller and smaller and smaller over time. And that's where the quality needs to become a lot more critical.
That's a great example. So you mentioned an example where the business could lose tens, hundreds of millions of dollars, and yet we still see issues with the data. So obviously management, senior management, they understand the need for high quality output for very accurate models. And yet in many cases, we still see people struggling with the data, struggling with the data quality. How does that align?
Well, I think that data quality is one of those things that not many people really understand the nuts and bolts of. I think conceptually they understand that quality is important, but tactically, I don't think they understand what quality really means in practice. And a big reason for that, in my opinion anyway, is that most of our executive leadership isn't exposed to bad data quality that much. So if I'm a CEO and I'm looking at a dashboard, and that dashboard is created by some, hapless business analyst, that analyst is going to work really, really, really hard to clean up all the messy data that they get to ensure that the final output that I see is acceptable. Now, that's a horrific price to pay on their side, and I probably can't really trust the data, but because it looks okay, right? There's nothing, it doesn't really break any sort of sniff test, then I, as the executive, am probably not going to question it. So I think that there's two things that really need to happen in order for this problem to start to be addressed more at the executive level. The first thing that needs to happen is there needs to be more of a more clarity on the consumer side of when data starts to be low quality. So, for example, if I'm looking at a dashboard, ideally, it should say in the dashboard how much I can trust the data that I'm looking at, right? 75% of this data is untrustworthy. If a CEO were to see that, the gut reaction is going to be, I don't want to look at this until that number is at least 99%. Then I can make some decisions off of it. But right now, they really just don't have a clue.
That's a great point, that they don't have a clue. I think that's probably the key. And one of the things that you advocate repeatedly are data contracts. Could you please share some lights on how that could be used, how that could solve some of the issues at least?
So so the data contract has is sort of a core technical component to it, but it has a few secondary benefits. The core technical component of the contract is that it is a mechanism for a data consumer to define the constraints for the data they need to have quality and consistency. And the contract is composed of two primary pieces. There's the specification. So this is kind of like an API spec. It's we use a YAML file, but it's some description of the schema, of the semantic constraints of the data, of SLAs, things like that. It's stored as code somewhere. We put it into a single Git repository. And then that contract, that specification, is mapped to a mechanism of enforcement. So there's some vehicle of validation that occurs programmatically and ensures that the contract is not broken. The reason that's really useful, the first thing you can imagine is it's preventative data quality, right? So it's not reactive. We're not waiting for things to break and then trying to figure out what happened. It's stopping low quality data from ever entering the system. That's number one. But the second thing that it does is it gives you a surface of defining what good data quality even is to begin with, right? So if you have a breach of contract, and it could be anywhere in a pipeline where you've set these contracts up, then you know that that particular data asset, it could be a table or it could be a row, however you're tracking it, is going to be low quality all the way through the pipeline. The garbage is in, so to speak. And so now that you know that, you can start to attribute trustworthiness to these data assets, right? Like this percent of the data in a table violated the contract, and that means that we can't trust it.
That's a great way of making sure that the data at least stays to some level accurate. And as you mentioned, to prevent low quality data from entering the system. Once it's there, who do you think is responsible to clean it, to remove it? Because that's probably inevitable. In any system, something could happen. Even if you didn't try, it could happen. It could happen. So who can make that decision? Will it go to the CTO? Will it go to the consumer level? Or do you think that those that are building and acquiring the data should make the effort?
I think there is an ideal and there is a reality. I think the ideal is that the builders are the ones who are fixing these issues, right? That's kind of how it would work in any manufacturing process where components of a larger system are passed off from, you know, engineer to engineer. If I build an engine and then I give you that engine, you put in a car and the engine blows up, it's my responsibility to fix, right? I would be the I as the engineering, you know, creator would be the one that needs to go and fix that. We don't really have that relationship between data teams and software teams today. I think that in the future that might start to happen, but I think what's more realistic for the time being is that we kind of try to we try to create as much visibility as we possibly can into how low quality data is going to harm consumers. I think that's a really big problem today, right? A lot of producers are just not even aware that their data is being leveraged for important use cases. And that's because typically these databases were spun up to support applications, right? You've got, oh, I'm running Facebook, or I've got Uber or something like that, and my database is ensuring that the transactional component of that application is working as expected. And so that's kind of what I built everything for. And so if someone then extracts that data from my database and they find some additional use case for it, I'm not really thinking about that. I'm not thinking about their use case and all the requirements they have of quality. But I would probably like that, right? If I'm a software engineer, it's actually a good thing for me to know who's using my data and how they're using it and what the dependencies are. I don't want to break people. I don't want to make life more difficult for them. At absolute minimum, if I'm going to be making changes that impact them, I do want to communicate that and just be a good citizen within the organization. Say, hey, you're using a column of mine and I'm planning on, you know, changing that column and bumping it to a new version and adding more data. And here's when that cutover is going to be, right? I think engineers would really like to do something like that. And in my opinion, that's the first step. And that does put the onus of fixing the data after something has already failed onto the consumer. But I think if you can solve that first problem and just get really good about communication and understanding where your data is going, it's going to knock the number of those sort of reactive use cases down by a pretty significant amount.
Like you said, in theory, it sounds really, really good. And in practice, at least in the software world, we have so many QA mechanisms to make sure that the software doesn't break, that that obviously the hardware doesn't break. I'm not sure that enough mechanisms exist or processes within the firm exist to make sure that the data doesn't break. Exactly like you said, people who own the data, who build the data centers, whatever you call them, they want to know what the data is used for. And sometimes they don't. Sometimes they make changes that are technical. Sometimes they make changes that are maybe temporary. They don't know how things will break because of that. And that's a shame. That's a shame. You mentioned that at the moment, those who build the data, who kind of own it to begin with, are responsible for maintaining it. Do you think that, obviously not the top level consumers, but do you think that somewhere should create an additional team to maintain the data, so it's not responsible of those who acquire it, in the sense that you have QA teams who are very separate from the software engineers that build software? Similar, maybe someone who builds the data infrastructure is not the person who maintains it.
I think that that's a good intermediary step in sort of transitioning to more producer-driven ownership. But my perspective is that ultimately, I think producers should take ownership, and we should try to be moving towards a world where the producers do take ownership. And my worry with having someone sort of in between that's acting as the QA system is that it creates a bit of a learned helplessness. And I saw this a lot at other places that I've worked, where it's like, hey, if I have someone whose full-time job is to take care of the quality, then that means that me as the producer and the creator of the data, I don't need to think about that anymore because I know I've got this person doing it. Whereas I think there will be a little bit of temporary pain and a little bit of temporary hardship, but I kind of think of the data contract and the ownership of the constraints as a similar type of relationship that product managers have to software engineers, where you've got a set of requirements that are produced from someone who understands the business and the customer. Those requirements are given to the engineer then implements, and they're responsible for any of the bugs that then emerge over time. And if there's something that the engineer doesn't notice, or maybe if there's new features that need to be built over time, then the product managers just get into this process of like submitting tickets, and producers, put that on their backlog and they resolve those. And I would like to see that sort of relationship start to emerge between data teams and software engineering teams. One of the big challenges in like, why I think there's a question of like, why hasn't this system already emerged already, right? Like, why is it that product managers have this great relationship with engineers? UX designers, you could argue, have a great relationship with engineers. Other engineers on the team have a good relationship with engineers. There's very strong change management processes that exist, but it doesn't really exist for data. And in my opinion, the reason is because data is inherently a lot more cross-organizational than all of those other functions are. If I'm a product manager, I'm usually writing a requirements document for someone on my own team. If I'm a designer, I'm building out a set of interfaces for an engineer on my own team. So there's sort of an incentive to do that level of collaboration, because that's the sort of work, we're all kind of working together. But in data, if I'm a data scientist and I'm building a pricing model, I might be pulling data from a shipments database that was built, in the first year of the company, and it's maintained by a group of folks that have been there for 20 years, and they don't even know I exist. And maybe I'm pulling in pricing data from, or I'm pulling in a financial data from our point of sales team, and they don't know I exist. And I'm pulling data from somewhere else. So I really need data from all across the company. And I think that that's actually the really big challenge to solve here, is like cross-organizational communication, which, interestingly enough, software engineers also have when it comes to managing their APIs, right? If you actually look at how APIs are used and deprecated within an organization, it's the same exact problem that we're talking about with data. It's just felt a little bit less because software engineering teams do have better processes, in my opinion, for managing this type of stuff. They have APM tracing, they have end-to-end integration testing, and there's still situations where you could deprecate a field or change a field in an API, and someone in the company is using that, and you get into trouble. But there are some processes that exist.
Yes, absolutely. You could get into trouble. That's I would imagine, from personal experience and from the experience of everyone on the call, you change something and you aren't aware of what exactly happens afterwards, and then you get a phone call and then another phone call. In terms of building a process within a company, if you were to advise to a medium-sized company, whom will you start working with? Will it be from the top level up or from the bottom level?
I prefer working from the bottom. I think that there are certain businesses where working from the top is the right idea. Meaning there are some CDOs, or there are heads of data or heads of data platform that are extraordinarily influential. They really understand the end-to-end process, and they can institute the sweeping culture change. I've definitely seen that before, and that's awesome when that can happen. However, what I find is most common is that the data leadership is really just trying to stay above water, and thinking of these like large strategic tactical changes are not in their wheelhouse. They're just kind of trying to ship things and deliver things. And the best place to start with this is actually the teams that are most impacted by data quality, and then kind of piggybacking off of them. Because in my experience, those teams are usually product teams, and those product teams are experiencing some type of financial impact, right? They're not able to hit their KPIs in the year because of a data quality issue. So they have an extreme incentive to fix this problem. And if we as the data team or the data infrastructure team can sort of piggyback alongside of them and say, look, we're going to provide you the infrastructure that will help you solve this problem, but you as the product organization need to be the primary advocates of it. Like that's something that I've seen, you know, like things really get done if that's the framework you use.
In terms of ROI, let's talk about ROIs. I am a team and I suffer. I suffer because the people need to work extra time to maintain some data quality, and I still can deliver high quality data to another product team or to someone else. I suffer, of course. I lose time, I lose money. I cannot build the things that are otherwise required. What would be the ROI in terms of if I were to introduce a certain system? How much do you think it will cost? How much time do you think it will take? And maybe if you have some examples of systems that you think are useful for those types of solutions, I think that could be useful for all of us to know.
Yeah, so I think it's going to depend pretty heavily on what the ROI of the team is already getting through data or what they expect to get through data. So as at Convoy, I've used the pricing team a lot because that's actually where we started doing a lot of this work. And we had a pricing model, and this pricing model was, I sort of mentioned how it was working. It was sort of predicting the potential margin of any shipment. And 100% of every single dollar that Convoy made flowed through that model and then back into Convoy's financial accounts. So if that model was doing a bad job, it had a really, really big business impact. And the product managers and the data scientists and the directors of engineering who worked on that team had quarterly goals to iteratively improve the amount of margin that we delivered from a pricing perspective. And the model was one mechanism, one lever that they could kind of pull to do that, but it was a very big and important lever. And so when we had data quality issues within that model, like either there were outages or there was some business logic change that was introduced in a database and nobody really caught it because it didn't cause a data type to change. It wasn't backwards incompatible with the schema, but it did make our predictions less accurate. And at some point we discover these, and bang, it causes millions of dollars in losses. I essentially went to that team and I said, look, imagine that your data quality was perfect. What would be the impact on you? And I want a number, right? Give me a number in terms of dollars and cents of how valuable this would be. And they were like, of course, we can go out, we can do some quantification. They brought a number back. It was in the millions of dollars, in the large millions of dollars, actually. And so then I could basically go to the executive team and say, hey, here's this number. This is what we are going to get every single year in perpetuity. And it's probably going to grow because we're going to need more data over time and our business is going to grow over time. So really, there's almost no investment that I can make on the infrastructure side that's not going to be outweighed by the ROI that we get. But that's sort of an example, right? And that's just one use case. There were other use cases that we found very shortly after, like one of the features that we were providing to our customers was kind of like a data API where we were making the status of shipments accessible to our shipper partners. So big companies like Target and Walmart, they were using our data on shipments to kind of figure out like, hey, what information should we be communicating to our facilities? What information should we be communicating to our facility managers and operations teams? So they were doing a lot of interesting things for that data and they were paying for it. And so if that data was wrong, then it's a really big deal for Convoy, both from like a branding perspective and also, it's sort of every piece of wrong data we give them just gets them incrementally closer to churning. And with really big accounts, could be extraordinarily problematic. So massive opportunity costs there if the data quality is low. And so to the second part of your question, in terms of how much would something like this actually cost, I think it depends on where you want to start and how complex you want to get. So there's some folks that I know over at Open Door, and they started with data contracts focusing on SLAs. And the reason why is Open Door is kind of a data-oriented business, and their perspective was, look, if we can just reduce the refresh time, so our data in certain very high-value tables is refreshed more frequently, that's going to allow us to be more up to the minute in terms of the prices that we put on Open Door, in terms of the recommendations that we make. And we think that that's going to have $1 million impact. And so we're just going to start with SLAs, right? And that was sort of their starting point. And it was very, very easy for them. In fact, it was almost free, right? They just went to those teams and they put together a business case and they said, hey, we always want you to hit this SLA. They had a contract. It was only documentation. And a lot of the engineering team said, sure, that's easy for us, right? It's very easy for us to just increase the frequently that we're pulling these logs. So yeah, if that's the business impact it's going to have, then we're obviously going to do it. But there's some things that are a lot more costly, right? There are some things where you really need to have more of the programmatic checking and checking the schema and checking the semantics. And there are a bunch of open source tools that do this type of thing. I'm sure there's going to be some closed source tools that do it eventually. There's a lot of data catalogs. DBT has a form of data contracts that they're sort of rolling out just for the warehouse. So I think the tools are going to start to exist more comprehensively over time. But for now, that's how we justify that implementation cost.
That's an amazing experiment that you did, an amazing flow. You went to the people who actually bled money and you asked them, what would happen if you didn't bleed? What would happen if the data is accurate? How much will you gain from it? And if that could be done on any level, whether or not it's a CTO, CEO level, or on a product manager, or on a much lower scale level, then the problem will probably disappear, because people will actually understand how the data quality will affect their teams, their entire business, their entire unit's performance, and they will want to implement whatever solution comes in handy, whatever relevant solution will be available, open source, closed source. They would pay a lot of money to get to that place where they don't bleed, where they actually are either level, or the data is so good that it actually allows them to do other things that they're not maintaining, right? Because you're spending money on maintenance, you're spending time on maintenance, and then if you don't do that, you have free time to do other things, to improve, and even to innovate, to enhance the business. So that's a great experiment. I hope it can be achieved in any of the places, in any company, big or small. Something that I think very is on the news, etc. Of course, the ChatGPT, these types of models. Do you think they are affected by low quality? Obviously, it's a different setup, it's a different infrastructure, a different domain. But do you think they are affected by low quality wherever they meet it?
Absolutely. I think that one of the dangerous aspects of these LLMs right now is that to the non-technical, advocates, I guess. So if you're at C-level, your CTO, CEO, and you really want to start implementing LLMs because you don't want to fall behind the competition, it's not always clear to you what is the cost of training one of these models, and where is the data coming from, and how accurate is that data? You're just not really thinking about that. And so the use cases right now are not really geared towards data in like a warehouse or some other analytical environment, but it's getting there, right? This is ultimately the place where people want to go, either so that you can be some random person in a company and you can ask ChatGPT, hey, what was the churn over the last 6 months, right? This is sort of a very common use case I've heard brought up a lot of times, but they want to do more than that, right? They want to say, hey, build me a predictive model off of user data over the last 3 months, and I want that model to predict whether or not somebody is going to buy any particular item. Like ultimately, like this is kind of where we're going, right? It's sort of just tell ChatGPT what is the data that you want to feed into the model, how do you want to train it, and what do you want the output to be, and maybe even not even telling it with the data you want to train it on. Maybe just say, hey, I want you to predict based on this, and then the model somehow by magic is able to go and figure out what that training data needs to look like. I think this is the vision that a lot of these executives have in their head, but they don't understand where their data is coming from. They don't understand how their data has changed over time. All the problems that we were talking about kind of in the beginning are just very nebulous and abstract to them. The data engineers all know, and oftentimes the data scientists maybe know a little bit, but the rest of the business is very kind of abstracted from these deep, like technical data issues. And so I think we're going to start to see a lot of folks who want to apply LLMs to their data infrastructure, and maybe they take that first step, and it'll be like anything else. We'll see kind of this peak of excitement, you know, the explosion of interest, and then we'll kind of see a plateau as the reality starts to set in that, okay, the data is very low quality. We're not, and honestly, this has happened before, right? You know, there was neural networks, and, you know, even if you go all the way back to applying linear regression at scale, like all of these things experience this very similar boom of, wow, we're going to be able to predict everything. And then the data quality monster kind of reared its head, and it got very, very quiet because people realized they needed to actually work with high quality data first. And I think, I hope, I'm always hopeful, and my fingers are crossed, that there's so much excitement about, you know, generative AI and LLMs, that this is really the thing that gets the CEOs and the executives to at least have the conversation about, you know, what is our data doing? Can we trust it? Can we trust it to feed into a model? Is it going to hallucinate or not? And once you start asking those questions, then I think a lot of the skeletons in the closet are going to emerge.
And then the solutions that you've discussed previously will be so much more exposed and used probably, and important, because now if some people are not aware of the impact, they might not deem those solutions as important. But once you ask ChatGPT or what their equivalent, and they start to hallucinate, then the CTOs, the CEOs will see what just happened. Where did that hallucination come from? Also, in terms of infrastructure, it requires a lot of curation of the data, of course. When you want to train that on your own data, rather than take some open source, whatever it's the latest and greatest, but still it wasn't trained on your data, and that requires a lot of detail-oriented flows, right? In terms of hallucinations and those mistakes that the LLMs make, how do you see us overcoming those? Just on a global scale?
Yeah.
Will they disappear, in your opinion?
I think it's a hard problem, and I'm not exactly sure how it's going to be solved. I definitely have some thoughts. You know, I might be a little, I don't know if anti-technology is the right word, because I'm definitely very pro-technology. But I think I'm a really big believer in human in the loop communication and just like human-based workflows. And I think we've seen with a lot of the collaboration tools across the various other you know, product disciplines, that they can be very effective. Figma is a great example of this. If you're familiar with like the design tool, it is awesome. It is a great system. And I've been using Figma a lot recently. And one of the things that you can do is you can sort of create a user interface as a UX designer, and you don't need to have any understanding of code, no understanding of any of this stuff. And the system will basically translate your designs into the CSS. And I think now they're even starting to translate it into React. So that's an awesome interface between the UX designer and the engineer. And this is already happening in other places. Like GitHub is sort of human in the loop, engineer to engineer communication. Jira is human in the loop, sort of project manager, product manager to engineer communication. And I think once we start adding the human in the loop when it comes to data, then I think a lot of these problems can begin to get addressed in a more narrow and sort of vertical type of way. The other thing that I'm a bit opposed to, I think, is this idea that horizontal solutions, or you can snap your fingers and a horizontal solution takes care of everything. That just hasn't been my experience. I actually believe a little bit more in sort of the vertical approaches, like we were talking about before. You sort of go use case by use case. And if you go use case by use case, then you have a set of constraints under which to operate, right? So one example is data lineage. Data lineage is a very challenging problem to solve, especially if you have lots of different data sources and lots of different transformations that are happening, and SQL queries that are 1,000 lines long. But if you're just trying to understand the lineage for one use case, then you can pretty easily map that back to all the data sources. It's kind of a constrained problem. So I think if you can combine things like column level lineage for specific, very high value data assets and a human in the loop communication for that data asset in particular. So if any, if you imagine this is a graph for one asset at the end of that graph, one sort of node at the end, and if there's any change on any of the other nodes, then you basically just say, hey, for this change to actually go through, it requires a data consumer giving you a sign off, right? Just something as simple as that, I think, would result in probably an order of magnitude improvement in the quality. Like we don't have any of that today. There's certainly changes that happen, right? You can say, oh, well, there's a change made to a repo and I want to subscribe to that repo. But as a data person, I don't know if this is a change that is relevant to me. I don't know that if it's actually going to break me or not. And so if I'm just getting a ton of these alerts and notifications, eventually I'm going to tune them out. So I think this is kind of the way forward, is being a bit more narrow, focusing on the use case, human in the loop communication. I think that is going to really improve the quality, and it actually allows you to train these generative models in a more narrow way, right? Like, here's the pipelines that we trust, and I'm going to train my LLM on that to start off with, and then incrementally add more as more data becomes trustworthy over time.
Cut in the loop is exactly, I think, the right term. From my personal experience, this is exactly what will be the difference between a good, maybe bad, maybe broken, maybe good plus, to a very good solution. You see that in vision as well, not only in an LLM. You see foundation models that can do a lot of great things that 5 years ago no one could predict they would do, but they do it on a 90% level, maybe 85% level, on a great variety, a huge variety of items. But if you go on a very specific domain, it drops significantly. And from that, there is no way but to have a human in the loop, maybe to work with annotation, with the curation of the data that is being used for the training, that helps that foundation model, that helps to train a smaller model, maybe. Exactly like you said, without the human in the loop, it will be maybe a good solution, but the hallucinations, the inaccuracy will definitely be there. And like with the initial convoy example, it could be tens of millions, maybe hundreds of millions of loss, because before we sign, one final question before we sign off, about data quality camp. Can you tell us more about it, if people want to join?
Absolutely. Data Quality Camp is a Slack group that I started in November of last year. We've grown to about 7,500 members, and it's a pretty, I try to be selective with who joins. These are all professionals. They are working with data at scale. So we have a very, very small number of people who, they've never worked with data before. They're looking to get into the field. So it keeps the conversations very high quality, very thoughtful, lots of opinionated people. And the reason I put the community together was mainly because these problems of data quality are still like, we're still kind of trying to figure all this stuff out. There's some things that I think we've got a relatively decent handle on now, specifically the monitoring and the alerting, right? Like there's a bunch of platforms that exist that are getting pretty good at telling you when something is wrong and maybe alerting you kind of after the fact. But there's a whole other side of quality, which is the preventative side that we've been talking about, the human in the loop side, that we're still really trying to understand, like what is the right way of doing this, and what should the responsibilities of the various stakeholders in an organization be? How do you get started? A lot of the great questions that you've been answered, we're also asking those questions in Data Quality Camp. So if folks are interested, I would really suggest you joining. I'm in there pretty frequently, both answering and asking questions myself. And the link is just dataquality.camp/Slack. And yeah, that's it.
Thank you. And what's next for you, Chad? What would be your next data problem that you're going to tackle?
Yeah, so right now I'm writing a book, so that's sort of the big thing on my mind. I'm working on an O'Reilly book on data contracts. I actually started off. Well, I didn't start off I actually began my career years ago as a journalist, and I left journalism, and I somehow made this transition into analytics, and then from analytics I went to data science, and then from data science I ultimately went into infrastructure. But I always wanted to write something more long form, and I thought that after my journalism days had passed me by, I wouldn't really get the chance to do that again, and now it's kind of come back in a very interesting way. So that's going to be my big focus, I think, for the next 6 to 8 months. And then on top of that, I'm working with a few companies on helping them implement data contracts and data platforms and data quality solutions and things like that. So lots of fun stuff in the pipeline.
Thank you. Looking forward to the book. Obviously going to be a great read. And thank you so much for being here. It was a great meeting. I think we all learned and got some answers for very tough questions. So thank you very much. Thank you. And thank you for everyone who attended. Have a great week.